Hi everyone and welcome back to my YouTube channel. In this video we discuss about the what are transformer and what are the basic difference between the BERT and the GPT model. The transformer is first introduced in 2017 in the paper called Attention is All You Need. The original transformer is developed for the machine translations just like English to German and French. But right now the transformer model is quite popular because the GPT model is available and GPT model is based on these transformers. So if I see that architecture of the transformer, I just write it down in the notebook. So in the case of transformer, it's just used for the language translation, right? So it having one input text and then it having some pre-processing step. If you see on that, you can see here, this is an example. Also have one input text and I'm going to translate them into the German language. So input text is going inside the pre-processing step. So in the pre-processing step, it will follow here some kind of technique called the tokenizations. That's mean it's converted the text into some kind of token. If you know about the NLP, you can you also understand that what I'm talking about. And after that, it will go to inside the encoder block. So in the encoder block, it having so many types of neural network architectures, just like the attention mechanisms as well as the feed forward neural network. So the encoder block is trying to converting here text into some kind of vector embedding. That's mean we having one input text which can take an input. Second, we have the pre-processing step where you need to do the tokenizations, and third step you need to follow here the encoder and it will convert them into some kind of vector embedding. And this embedding is passing to the decoder block. Now what is the encoder? What is the vector encoder? So if you see this paper, let's say I have one examples that you can see. It have the king and man, woman, apple, banana, orange, as well as a football, golf and tennis that you can see on here. Okay, so see, king and the man is nothing but go inside the different cluster of the persons, and apple and the banana and the orange is go to the cluster of the fruit, and the football, golf and the tennis is go inside this game that you can see on here, right? That's mean it will try to convert them into some kind of clusters because it will using here a mechanism called self attentions. So what actually happening in the case of tokenizations? So in the case of tokenization, it will actually give here some kind of random and unique value. So in kind of the vector embedding, it will try to convert them into some kind of vector so that the self attention can process them. Now, what is the self attentions? So self attention is allow the model to weight importance. See, weight importance. That's when it have the neural network. So weight importance to different word token relative to each other. See, if you see this example that you can say king, man and the woman, it have different types of cluster, right? That you can see on here. That's mean in the case of self attention, it will try to give some kind of more attention to the each word. Let's say I have one sentence. Let's say I play football. I have the another sentence. I play an important role in the society. See, play in the case of football, it will meaning the different. I play an important role in the society, it's also different. That's mean it having some kind of attention score. So this is how the attention mechanism actually work in the case of transformer, and this attention mechanisms makes a transformer very cool. And after that, our GPT is coming to the picture just like the chat GPT, right? That's mean transformer is the mother and GPT is the son, like that. So in the case of transformer architecture, it will just consisting here the two things. One is called encoder and another one is decoder. So encoder mean encoder input text into the vector that you can see on here, and decoder generate the output text from the encoded vector. That's mean if I see the decoder block, you can see the same thing. I just convert this is an example, my input text. I just convert them into the German language. So you can see on that input text, it will do the pre-processing steps, and after that it will go inside the decoder block and it will give the output layer. And you can see it will first passing here dust in. I'm not expert in the German language, so I need to convert this word. I need to predict here the next word called the example in the German language. That's mean the transformer is generating here the next token. Next word predictions. So that's mean this is an example. It's nothing but English, and we passing here dust in the case of German. It will predicting here this Beispiel, the German language that you can see on here, right? Same thing. That's mean transformer is used to predicting here the next word. Now, what are the questions about the what is the BERT actually? So BERT is not even the latter version of the transformer. The BERT is it's called the bidirectional encoder representation from the transformer. That's mean it have different types of directions. It can go to the left, it can go to the right. Now why? Because the job of the BERT is to predicting the hidden words in a given sentence. Just like in the class 8 or 9, we filling some missing value, right? I mean filling the missing value in the English exam. Let's say I have one sentence, I play dash. So I play football. Okay, that means see, let's I have another example. This is an dash of how LLM dash perform. So you have two dash. That's mean you have to fill in the missing value, right? So filling the missing value in the case of I need to checking the left portion what the was it talking about in the right portion as well. So that's why BERT is used in the case of filling the missing value like that. Also, BERT is and good examples of the sentiment analysis, because in the case of sentiment analysis, we need to reading the full text. You have to get in the sentiment, right? So, but also BERT is also called the encoder only model. That's in BERT is not a transformer itself, because in the transformer it have the encoder, the decoder, but a BERT is a transformer. Transformer is not a BERT like that. So that's mean in the case of BERT, we having one encoder. We have the pre-processing step, then we have the input text. Sorry, we have the input text, we have the pre-processing step, and we have the encoder. That's when BERT is nothing but an encoder only model. So in the same case of the GPT, it's also called the generative pre-trained transformer. The extent generative pre-trained, that's mean this model is already trained. It's called the foundational model in the case of GPT. So GPT work is nothing but generate the next token that you already saw that. So it will have the decoder. That's been GPT also called the decoder only model. It just have the decoder, it is pre-processing it, and it will same taking the input text from here that you can see on here GPT model. So it have the decoder, it has the pre-processing, it has the input text. In the case of BERT, it have the encoder, pre-processing input text, same thing like that. Okay, that's when the BERT is used for filling the missing value, or it's basically developed for the sentiment analysis. And GPT right now is popular, you know, the chat GPT, the DeepSeek R1, Google Gemini is nothing but based on this GPT model. So what are the examples of the BERT? So I mean applications inside the BERT. So you can take it the example of the Google search engine, same thing, as well as the Google Natural API is the example of the BERT. And in the example of the GPT model, it's nothing but the chat GPT, DeepSeek R1, same thing. Okay, so that's it for today. Now in the next one we will try to discuss about the more topics about the AI, because this is the foundation of the right now the era GPT model. So we discuss the another topics in the later on. So thank you for watching the video. Please subscribe this and share it with your friends.